Thanks for joining us, everyone. Good evening. This is Cyber Security Mentoring Group, a platform where we'll share, we'll learn, and we connect with professionals. Today, Saturday, 21st of March, 2026, we are looking at an interesting topic in cyber security. It's applicable to every field, but we are looking at AI in cybersecurity, or foundations of security in AI. And it's kind of interesting how we suddenly caught the wave of AI and the role it's playing in cybersecurity. And I'll just share one very foundational application that I just use maybe today. So I'm doing some research in cybersecurity frameworks, regulations, certification, and standards. And I just went to one of the AIs and I just needed that entire list. And I gave it a prompt, and the prompt was for it to be able to give me by country, by industry, and some other information. And within some few minutes, I got an entire database of all, well, as the AI would decide, cybersecurity certifications framework, and it was able to even break it down to what is mandatory and the different versions and the years of different versions. So that's just a foundational application of AI, or what AI can do for you. So we are today looking at the foundations of security in AI, and we have our facilitator. TOLUWANI has been a friend of the house and has been on our session before, where we had a conversation, one of our Saturday session, and we had a conversation about this topic, and we thought that it is important for cybersecurity professionals to have some, tips of the iceberg of this discipline and what it is going to do to you if you are able to master AI. So without much announcements, I will just give the floor to TOLUWANI to share his screen and then take us through. So just for information, this is a two session course. We will take one today, 21st of March, and the next one will be next week, Saturday. And as you know, we have our chat with professionals on Saturday also, but this will happen at this time next week, Saturday. So you will get a part today, and you will get the completing part on the 28th of March. All right, I will go the background and TOLUWANI will take it. I think we'll do about 1 hour, 30 minutes, but the first 45 minutes, TOLUWANI will share. We'll take maybe 5 minutes body break and come back for the remaining 45 minutes to complete the session. Thank you, TOLUWANI. You can go ahead now.
Wally, please, can you confirm if you can hear me now?
Loud and clear.
Okay, that's fine. And can you view my screen?
Yes, I can see your screen.
Okay. Thank you very much for the invitation to facilitate this session. And I also want to extend a very warm welcome to everybody who has taken out time from their busy schedule to join this conversation. And today we'll just be having some chats about security in artificial intelligence. And of course, I know that for most of us on this call, artificial intelligence is not something we are hearing for the first time. We have used it in one way or the other. We've experienced it one way or the other, either in our personal lives or in our work life, and um, it's becoming the center of conversations. If you are a leader or anybody sitting on a board and you're not saying anything relating to artificial intelligence, if you're a team lead and you are not talking to your management about improving your productivity or that of your team with artificial intelligence, then it looks as if you are not in 2026. The major conversations around information technology is beginning to gravitate towards artificial intelligence. And for cybersecurity professional, if technology is tending towards embracing artificial intelligence, then it is that means it's something we really need to focus on in providing governance, risk compliance, and security for this new baby that everybody's talking about. So today, like Wale said, this is going to be a two-part session, and today we're going to look at the first part. So for introduction purposes, my name is TOLUWANI AKINNIYI. I'm an information cybersecurity consultant, and I also provide VCSO services. So without wasting more time, um, yeah, I'd like us to go ahead. And basically today, for the first part, we'll be looking at three main topics. The first one is the AI security landscape. We'll also look at AI governance and regulatory frameworks. And the third one, we'll have conversations around before we wrap up for today is AI risk assessment foundation. So for the AI security landscape, we'll be looking at AI, the new threats and vulnerability that AI brings into the technology landscape. And of course, for us to be able to secure AI, we need to provide governance, risk management, and compliance. Thankfully, there are a lot of governance and regulatory frameworks. Some uh, national regulations, government regulations, some are industry based, and some are self regulated, where some organizations bring it on themselves to bring together different frameworks uh, to customize governance for artificial intelligence within their organization. Yeah, the learning objectives that I hope we all can get from today's session is to understand AI security, the core security challenges that AI brings to information technology, cyber security, and also to identify key AI threat categories which are not limited to adversarial attacks, data poisoning, and model thefts. We'll look at a couple of them. Then also how to apply relevant governance frameworks, such as we'll just touch on about three today. There are a lot of them, and that's the ISO for 2001, the EU AI Act, the NIST AI frameworks. There are a lot of other frameworks in the UK. There's a UK AI Act, and different countries or several countries are beginning to come, several countries and several regions are beginning to come up with their um, national AI specific cybersecurity and information security governance frameworks. Then also, just in closing, just discuss some tips on how to conduct AI security assessment across the AI lifecycle. Yeah. So why does AI security? Why does it matter? Why are we even here discussing about AI anyway? And why are we discussing about security of AI? So, like I said earlier on, everybody, every organization now is talking about AI, is implementing AI in one way or the other. So it's either organizations are using ChatGPT, staff are using ChatGPT in their private, for their private life, for their private learning. And what we've come to discover is that even for organizations that are ignoring AI or have decided not to use AI, um, we begin to find instances of shadow AI where staff are now importing artificial intelligence tool into their work streams to make them more efficient. And that is even a bigger risk for organization. So at board levels, at national levels, at corporate levels, we begin to find AI conversations about making AI, using AI to make work stream faster. Now, about 77% of enterprises use AI in their work operations, either ChatGPT, Microsoft Copilot, Anthropic Claude. There's a host of them, and because we're beginning to use AI for productivity or to drive our business processes. There are now beginning to be AI related attacks, either AI increasing the surface area for threat, or AI fueled attacks, because the same way we use AI to, or we employ AI in making our productivity more, cyber criminals are now using AI too. They're employing AI in conducting cyber attacks. So there's an estimate of $300 billion that is the annual cost for AI related incidents. Then, since 2003, there has been 3 times increase in AI attacks. And that's because AI systems introduce fundamentally new attack surfaces than traditional cybersecurity approaches. And the current traditional cybersecurity approaches we have does not adequately address AI attacks or AI risk. Therefore, as cybersecurity professionals, we need to focus on AI, the new risk they portend, the new surface areas for attacks that AI has brought into the landscape, and how we can combine technical governance frameworks and ethical consideration in reducing the risk of these attacks. Quickly, we'll discuss what makes AI systems unique. AI systems are distinctly different from traditional IT systems that we have. And I'll just give four. There are lots, but we'll just give four for conversational purposes. Number one, traditional software or traditional infrastructure. They are written so for softwares that we have previously, traditional softwares, they use explicit rules. They are rule-based. So if you put an input, the system is being guided based on the rules that has been set in the application on how to process that input to give specified outputs. But then AI systems are not like that. AI systems are non-deterministic and they are data-driven, such that when you put an input into AI, the AI processes the input based on the data it has or based on the data that's available to it. And such data is now becoming a critical asset for AI system. It is data driven. Also, AI gives probabilistic outputs. For traditional systems, for traditional softwares, there's a range of expected output based on hard-coded instructions in the uh, in the software code. But this is not the same with uh, AI, because AI keeps learning, it keeps improving itself, and definitely the way it treats inputs would vary from time to time. And this is bringing a lot of risk, because now we now need to define, or it's making it harder to define, what is the correct behavior. And how are we going to detect if the AI is giving us an output or is giving us interpretations that we don't, that is wrong. Also, for AI as well, there is, it brings an additional risk of opacity and explainability. Of course, for traditional softwares, it's easy to explain how the system works because there's a code, so there's an input, there's a processing, and there's an output. There is expectations of the workflow or the work stream, and it's easy. So, for example, if you are using the usual, probably let's take Excel, for example. 1 plus 1 will always be 2. If there's no 2, you just need to look at what you've put in the cells, or if you've put some other instructions for it to give you another kind of output. But for AI, it is not the same, in the sense that AI uses models to make specific decisions. And because of this, it is difficult, because as the model grows, as the model becomes more complex, it becomes difficult to explain how the AI model or the AI tool is generating the output that is being generated. And this black box nature complicates auditing, compliance, and incident investigation. Then, of course, AI tools or AI systems evolve because of the continuous input of data and learning from learning and continuous learning. Therefore, there is a risk that these models can drift. There's a risk we call model drift or degrade. depending on the kind of data that we are feeding into the AI systems. Or this AI system can be manipulated either intentionally or maliciously. Therefore, for AI systems, security is not a one-time assessment. It requires continuous monitoring throughout the entire AI lifecycle. Yeah, so we've had conversations around this. Traditional IT systems are rule-based, they are deterministic. AI systems are probabilistic and they are non-deterministic. AI systems are data-dependent and they have fluid boundaries. For traditional IT systems, they are well-defined boundaries in the sense that you've set up a system, you know where the inputs are coming from, you can really define your boundaries. But for AI, because we need a lot of data, so at times it is difficult to be able, in our data provenance, to be able to track where these data are coming from. Also, for traditional IT systems, there are known attack vectors that, because this system have run for several decades, therefore we know what to expect. But for AI, because AI is maturing day after day, so there are new attack vectors, and these attack vectors begin to change in their operationalities as time evolves. Also, there's a for AI, for traditional IT systems, a code has been written. If anything is wrong, we go to the code. But for AI system, because the model keeps learning, it gets to a point where there's a black box where even those who develop it cannot really explain why the AI system is churning out the kind of output it's it is churning. Then also it's churning out. Then also we've already discussed about binary behavior. We can track the behavior because for traditional IT system is input, processing, output. But for AI system, because it learns, then depending on the kind of data we feed into it or the kind of exposure we give to these tools, it degrades with time. What this means is that with time, if we don't do proper training, proper data sanitization, then the AI system begins to drift, begins to give us outputs that is different or that is biased from what we are expecting it to give us. So that's just the basic difference between traditional security and AI security. And what does this mean in real life? Our traditional security will not help us. The usual perimeter firewalls and the usual security practices that we have needs to evolve because the threat landscape is evolving. Then testing becomes harder as well because you can't just do only static testing and feel you're fine. This is a system that learns and evolves. So other type of testing, other types of monitoring are now involved. Then also incident management is now different from what we used to know it as. Previously, the way we manage incidents for traditional IT systems, we can't take that approach or we can't use that approach for AI system. And also compliance is evolving. Previously, we just had the 27001 and other information security frameworks. But now the advent of AI is beginning to have evolving compliance for frameworks such as for 2001 that focus on AI security, the NIST AI framework, and also regional AI framework that focuses on new risk that is being introduced as a result of implementing AI systems. Now, so at this point, we just discuss briefly about the new attack surface, the new type of threats that AI brings into our technology mix. The first I'd like us to talk about is adversarial attack. And adversarial attacks are just basic attacks that are crafted to ensure that malicious inputs are put into the AI system to enable it make wrong prediction or classification. Adversarial inputs to cause the system to make incorrect predictions or classification. Also, we have data poisoning. And when we think of data poisoning is targeted at training data. So the way AI system works is that we train data we train a model through data via an algorithm to make it behave in a particular way. So what data poisoning does is that basically it focuses on corrupting the training data, so such that the integrity of the model and the uh, behavior of the model is compromised. So data poisoning focuses on training data. Then model inversion. Model inversion basically is extracting sensitive data or sensitive information, such as personally identifiable information or information about the model's working or the way the model is set up from the AI itself. So it's about crafting malicious input to ensure or to make the AI system divulge sensitive information such as uh, PIIs or data about the system's internal working. That is model inversion. Then for model theft, of course, different organizations that are developing AI, they are developing models. Copilot has his model, ChatGPT, they have their models, and organizations that are also developing proprietary AI systems, they have a model. So the model theft is actually stealing that model, stealing intellectual property, and now using it for personal or for uses that are different from what the model was meant to be for. That is model theft. Then there's also supply chain. A lot of organizations use third-party AI tools or AI model. Like most organizations use Copilot, most organizations use ChatGPT. A lot of organizations and software developers are beginning to embrace Anthropic Claude. And what is done is that using these AI models or AI tools at times involve us imputing data into them or imputing machine learning libraries into our software development environment. Therefore, if there are malicious codes or if there are malicious codes or if there are any vulnerabilities in this model that we are using to increase our productivity, then that means we are opened a new vista. We have opened a new surface area for attack. Also, there's something we call prompt injection, and basically what prompt injection does is manipulating inputs. So prompt injection is manipulating inputs. And what prompt injection does is that it wants those inputs, aims to ensure that the systems overrides instruction and extracts information. So there are a lot more, but for conversation purposes and for lack of time, these are the six we're talking about today. Now we just look at how they work. So how do they work? Adversarial attack. So for example, an attacker adds noise. So for example, for image classification systems. So what does adversarial attack looks like? You know, the way the AI system is able to classify image system is that it understands the pixels, the pixels, so, and it's been trained that way. So it's been able to, and there's a way it can categorize a dog different from a cat. But just manipulating one or half pixel within that whole image gives it a new or totally different meaning from what the AI systems understand this as. And this, we can think of this as an optical illusion. So for example, how can this work in real life? For self-driving cars, the AI system has been trained on how to recognize a red light, that means stop. But if an adversary is able to manipulate the way the AI system understands red, meaning stop, by just adding something to it, then the AI system becomes fuzzy and it doesn't adequately recognize the red light that means stop. instead of it stopping at the red light, it keeps coming, it keeps going, and that can cause accident, that can cause loss of life. So that's just an example of adversarial attack. And next week we'll be having conversation on the controls that can be implemented to reduce the risk of these attacks. Data poisoning, of course, we discussed earlier. Data poisoning. What is data poisoning? Data poisoning is basically injecting malicious samples into training data. And why is this dangerous? This is dangerous because the training data is how the AI system learns its behavior or how to process information. So if the training data has been manipulated, or if the training data has already been injected with malicious code, then that can provide backdoors to the system. And also that means the person who has manipulated that training data can also control the way the AI model or the AI tool is going to behave, which will be different from the original purpose from which it was set up. And let's look at an example. So we have AI tools that can do spam filtering for emails. So in the process of training data, or training data that we want to use for a spam filtering system, imagine that this system has been trained on poison data. So instead of it blocking, the system will now be confused on how to classify emails. So probably something that should go to spam, or something that is a phishing mail will now pass through the system, because the system's training data has been compromised. It doesn't know how to adequately classify data. And of course, how can we defend against it? That is data provenance tracking, data sanitization. I will look at that in detail next week. Then for prompt injection, this is what for prompt injection, this is where an attacker embeds malicious instruction in text to a large language model process. So what this does is that it overrides its original system prompt and safety guardrails. And also this is dangerous. So basically it gives hidden instruction that the developers or the data scientists are not aware of, in websites, documents, or email that large language model retrieves and process. Therefore, what it does is that it silently hijacks the model's behavior. Model inversion, yeah. So model inversion um, is basically making an AI tool to divulge sensitive data. So for example, if we are using a medical tool, what the model inversion attack tries to do is that it attempt to make the system divulge the kind of data and sensitive information, probably medical records on which it was trained on. So that, and when someone is doing a model inversion, what they are doing is they are trying to potentially reverse engineer the model's prediction. Then we have model theft, that is accurately stealing the model, making an exact copy and using it for other uses that is different from what it was intended to do. Then for supply chain, we download a lot of pre-trained models, and they are on public repositories, Hugging Face, GitHub, and they may contain hidden backdoors. And this might mean that we have introduced compromised ML libraries with compromised data sets into our technology infrastructure. And of course, that causes that causes some compromise within our infrastructure. Yeah, so there are some use cases of real world AI scenario incidents. There has been a Tesla autopilot adversarial attack where, like we said earlier, someone just manipulates road signs, and the self-driving cars cannot adequately interpret the road signs, which can lead to accidents and loss of life, and also trick the car to go above the speed limit. Also, data poisoning that has it keeps happening. There's an example that happened in Microsoft. Then prompt injection. There's a ChatGPT prompt injection that allowed web content to extract system prompts. Then also there has been a lot of supply chain attacks for AI models and AI systems and AI systems. Yeah. So the next thing we'll discuss today is AI governance and regulatory framework. So now that we use AI globally for different use cases within our organization, a lot of some organizations have gone ahead and they have developed governance and regulatory framework through which we can implement and ensure that we govern AI systems adequately. An example is the ISO IEC for 2001, that is the Artificial Intelligence Management System. There's also a regulatory act. ISO for 2001 is not regulatory. Organizations can implement that to improve their AI governance, risk, and compliance. But the EU AI Act is regulatory and is compulsory for organizations that operate within the EU. The NIST AI framework as well um, is not regulatory like the EU AI Act. And of course, there is the UK AI regulation that has come into force. And what are these? Basically, all these frameworks, all these national regulation is aimed at regulating the use of artificial intelligence within critical sectors of the economy. Yeah, so first we'll talk about ISO for 2001. That is the AI management system. For those of us on this call who are used to ISO standards, there are several ISO standards. There's the 27001, that is the information security management systems. There's 20,000, there is 23,001, looking at specific areas of technology. But the for 2001 focuses on AI management system, and it follows the it follows the ISO's traditional documentation. For all ISO systems, 4 to 5 talks about context and leadership, because again, for AI is like all other information system. And of course, there should be a scope, there should be a context, and we should be able to prove organizational leadership for AI management system. First, the scope. What are we using AI for within the organization? Why do we need AI within the organization? Are we using AI for software development? Are we using AI for document analysis? Are we using AI for spam filtering, for fraud detection? First, the organization should come up with a use case for the AI. And when the organization comes up with the use case for the AI, there should be leadership, management, there should be management involvement. There should be an authorization from management for the use of this AI system. So clause 4 to 5 of the AI management systems, which is same thing for ISO standards. Look at the organization's context, stakeholder needs. Why do we need AI within the organization? What are we using AI for? And who are the stakeholders that needs AI within the organization or within our business? Do internal staff need AI? What do they need AI for? What departments within the organization needs artificial intelligence system? What do they need it for? Also, do we need to provide AI capabilities within our service offerings to our customers? So all those decisions are made at within clause 4 to 5. Then also management has to make commitment to the use of responsible AI. This phrase comes along a lot within AI. It's not just the use of AI, but responsible use of AI. And when we say responsible use of AI, we look at AI used under two perspectives. Number one, for safety of human life, for safety of human life, and also responsibly using AI as a member of the ecosystem, a member of an industry, and a member of a country. So using AI, we're not expected, all the AI frameworks are again using AI for malicious purposes and also for endangering human life. So uh, clause 4 to 5 requires that management commits to the use of responsible AI. Then also for clause 6 to 7, that is the planning and support. Here we now need to develop processes and procedures to ensure that we use AI properly within the system, and also that AI delivers value, business values to the organization, and also to ensure that AI helps the organization to achieve its strategic objectives. And that is where we set up objectives, we set up the processes for risk assessment. Also, management provides resources for the usage and the monitoring of AI. And also, this is where we define competence requirements. And when we are talking about competence requirement, is in diverse category. First, we need to look at, are we looking at developing an internal AI system, or are we going for an off-the-shelf AI system? If we are developing an AI system in-house, then we need to now look at competence. So what skills do we need our data scientists, our software developers to have to be able to support the development of the AI? Also, either if we're using an in-house built AI system, or we're using off-the-shelf AI tool, we need to train all the users on responsible use of AI and the acceptable use of AI within the organization. Now that we are using AI, what are the do's and don'ts of the AI system? And what are the penalties for using the AI systems in the way that is not prescribed or the way that is prohibited within the organization? So clause 6 to 7 help us in planning and support. Then clause 8 to 9 is the operation and performance. So if either we have decided to develop AI in-house, or we are buying off-the-shelf AI. At some point, after testing, implementation, the AI now has to do its work, has to support business operation. This is where the rubber hits the road. And here we now need to manage the AI lifecycle management. We need to monitor the AI system to ensure that the AI is doing exactly what we have implemented it to do, to ensure that the AI system is delivering value, that we ensure that the organization meets its strategic objective. And how do we do this? We develop KPIs. We develop KPIs, and these KPIs should be measurable. We set up measuring mechanisms, and also we review the system from time to time. So clause 8 to 9, within clause 8 to 9, there's a requirement for internal audits, because periodically we need to look at this AI system and we need to measure them against the set KPIs to ensure that the AI system is delivering value, is doing exactly what we have implemented it to do. People are using the AI system the way we have implemented them to the use. And of course, there's a saying that whatever is not monitored cannot be improved. And if we don't improve a system, the system goes backward. So there's clause 10 in ISO for 2001 that speaks majorly to continuous improvement. So now that we've gone through clause 4 to 5, where leadership has provided support, they have already mapped out stakeholder needs, the leadership has committed to responsible use of AI. We've gone through clause 6 to 7, that is the planning and support, where we do risk assessment, we set objectives, management allocate resources, and we have already determined our competence requirements. We move to clause 8 to 9, where these AI systems now become operational. We have already set defined KPIs, we've done internal audits, we are doing our measurements and monitoring. Of course, in process of operationalizing these AI systems and doing our performance management, we find some gaps. probably some minor non-conformities, some major non-conformities, or we find some opportunities for improvement, because we can always make it better. And clause 10 looks at continuous improvement. So all the performance gaps that have been identified within clause 8 to 9, how do we remediate those gaps? How do we undo non-conformity? How do we implement corrective action to make sure? And also, again, in the use of within clause 8 to 9, when we begin to use this system when we begin to use AI in our system, there might be business upgrade. So there might be needs to either increase the use of AI within the organization, or there might be new use cases for AI within the organization. So again, when all these are discovered, they help us to improve the performance, either the performance of the AI system, or to ensure that we can see more use cases for AI within the organization to bring additional value for to customers, to stakeholders, and to staff, also to increase productivity within the organization. So ISO for 2001, the the clauses, the way the clauses are structured is not different from the way 42,000, the way 27,001, the way 20,000, the way 23,001 operate. But then what he has is what the unique difference with it is that it is specifically for AI management systems, and the controls that are within the 42,001 are specific to they are specific to AI systems, to artificial intelligence systems. Yeah. So again, in implementing for 2001, or using for 2000, what are the key takeaways? First, AI policy and objective. That is clause 4 to 5. That is where the organization establishes AI policies, defining responsible AI use, set measurable objective, align business goals, and communicate these across the organization. Also, there's a requirement for AI risk assessment. And basically, what does this do? Is a process to identify, analyze, and evaluate AI specific risk, including bias, safety, security, transparency, and societal impact. And when we say bias, what do we mean by bias? Bias is the risk of AI system giving uh giving output that is not representative of an entire population. I'll give an example here. So there's been a case where one of the top organizations that we know globally had an HR2, an AI HR2. So what this tool was doing was that it was filtering CVs for interview. So what they found out using this AI tool for a long time was that a long period of time was that this AI tool was actually screening out female applicants. When they discovered it, they stopped using the tool, and of course they conducted some investigation. And basically, what they find out was that this tool was trained using biased data. The data that the training data that was used in building the system was focused largely on males. So in its operations, it was filtering out female applicants. So when we say bias, bias is either towards a demography, towards a societal class, or towards race. Basically, what we're saying is for bias is when an AI system brings or churns out output that is not representative of the total sample set or the total population. Also, AI risk looks at bias. It looks at safety, especially for AI systems that are used that are used in healthcare, that are used in law enforcement, that are used in industrial systems, AI systems that are used for automation, self-driving cars. We're looking at the safety, because nobody wants to use an AI is a self-driven car, AI car that cannot interpret road signs effectively. That is a disaster waiting to happen. Also, the security of this AI system, the confidentiality, the integrity, the availability, the privacy of the data that is used in training AI model. Also, transparency. Black box, like I said earlier, black box is becoming a risk in AI system as they mature. So, how do we do documentation along the way to be able to, so that when an AI system makes a decision, we can transparently say, okay, this system has made this decision based on XYZ variables, and also the societal impact of AI system. That is very important as well. And our risk assessment should cover this, because AI systems are beginning to have profound societal impact. One that all of us can resonate with is deepfakes. So now you go on social media and you see a video, somebody is saying something. So there's a video about someone that is either doing something or saying something, and at the end of the day, we now find out that it is fake. It was doctored. Most times they say it's AI generated. So, and the kind of societal impact this causes, it might have brought down someone's reputation, or it might make a demography start thinking about another demography in some kind of funny ways, which is not supposed to be anyway. And people use AI tools for a lot of these negative things. So we must, for our AI assessment, should look at risk of bias, safety, security, transparency, and societal impact. Also, the risk assessment should be documented, and we should have a determined cadence for risk assessment, annually, quarterly, uh, half year, the time depending on the risk profile of this AI system. Then also AI impact assessment also. What is the impact of using AI in our organization, the impact on individuals? There are a lot of conversations, there are a lot of conversations within organizations or within industry that AI would replace humans, that a lot of people are going to lose their job because of AI. Now, if we are going to implement AI within an organization, we should look at the impact on the individuals. How can we assure our staff that, okay, these AI systems is going to improve productivity, and re, we're not replacing all of you with AI systems? Then also the impact of AI on society, especially for industries that are heavily regulated, for industries such as law enforcement, for industries such as medicine. What is the impact of AI? And for impact assessment, we looked at things like fairness. AI systems should be able to provide outputs that are fair. Then, very importantly, for critical sectors such as healthcare, law enforcement, there should be human oversight. So, what we mean by human oversight is that for critical systems, AI should not make the final decision. When AI makes a decision, human beings should review what the AI what the AI is suggesting, or the output of the AI, to see whether it is accurate, especially for in medicine, because we are now AI is beginning to do imaging, and we are getting fantastic results. AI is beginning to detect cancer, detect tumors, and some kind of malignant issues faster than human beings. But then the global best practice is that for these critical systems, especially medicine, law and enforcement, credit systems, you apply nowadays, you find that you want to apply for credit, or you want to apply for credit or overdraft. Then on your banking app, it asks you for some information. It rolls and turn. Then it tells, okay, you are not allowed this overdraft. You are not allowed this overdraft, or you're allowed this credit. There should be human oversight to ensure that the decision the AI is making is accurate, because what that does is, when the AI system is being found out to make decisions that are inaccurate, it reduces the trust, and people don't want to use it anymore. People don't want to rely on it anymore because it brings unintended consequences. Then also data management. AI is all about data. We train models based on data. Now, for data management, we want to look at the quality of the data that we are feeding into the AI system. The provenance of the data. When we talk about the provenance of the data, we're looking at the history of the data and the life cycle of the data. Where is the data coming from? How many people have manipulated this data or they have worked on this data before it has gotten to us? Training data must be documented, and data protection measures must be implemented throughout. Next week, we'll look at privacy concerns in artificial intelligence management system. Then also for 2001, critically looks at third-party controls, because for most of the AI tools we're going to use, there will be third-party tools anyway. And it focuses on due diligence on AI components from third parties, including pre-trained models, APIs, and data sets. So the requirement here is that every organization that is using third-party that is employing third-party AI tools must have governance standards for these tools. These tools must meet an internally defined criteria before we implement them within our information processing facilities. Then, of course, continuous performance. There must be continuous performance monitoring. There must be regular internal audits of the AI management systems. And also, very importantly, there should be management review. So after we've set our KPIs, we've monitored, we've done internal review, we should report periodically to management at the minimum annually on the workings or on the operations of the AI systems, so that management is aware of how the AI is functioning. If there's any risk that we need to bring to management's attention, we bring them to management attention. If there's any risk also that we have discovered from our impact assessment, they are brought to management. They are brought to management's notice, and of course, because they are the ones ultimately responsible for risk management, ultimately accountable, pardon me, for risk management within the organization, then they are able to make decisions that about those risks in line with the organization's risk appetite and also strategic objectives. Yeah, so at this point, Wale, will it be nice to take the 5 minutes break now, or do we continue?
Yeah, thank you, Toluwani. Let's take a 5 minutes break, body break, and we will get back at, depending on where you are, it's 4:52 now. It could be 5:52 where you are. So we'll get back. Let's get back on the dot, on the dot of the hour. So we'll then take the last 30 to 45 minutes to complete the second part of today's class, and then next week we'll complete the part 2. Right. 5 minutes. Just come out at the top of the hour, then we'll continue. Thank you. Let me pause the recording.
Yeah, so I think yeah, I can take the question now. That's fine. So the question is, what's your take on an organization actively using AI within its system, yet has no defined policy or governance around its operation? So, thanks for this question, Winnie. And for me, this is any organization operating this way is just like an ostrich burying its head in the sand. There's a disaster waiting to happen because of the criticality of AI systems. So this happens in organizations in two ways. Number one, there's some organization that uses AI within their system, but yes, they have no defined AI policy. There are some organizations that are not even that they don't use AI within, there's no official use of AI, but they are not aware that staff are beginning to download AI tools and use AI tools within the system, shadow AI, where the organization is not even aware at all that AI is being used within the organization. So this again has a lot of, depending on the industry the organization is operating in, it might have some regulatory impact. It might have privacy impact because hopefully these staff are not imputing personally identifiable information into unsanctioned AI systems. And also, it might have some regulatory implication, especially for medical system, for law enforcement system. So the best thing is every organization operating in 2026 should determine how AI will be used within the organization. Every organization should have a defined AI policy, a defined AI acceptable use policy, and a defined AI management policy that talks about governance and the use of AI within the organization. So yeah, I can see that there are other questions, but I would like to continue the last part of the um, conversation today. Then after that, we'll come back to the question. So I'm going to share my screen shortly. Yeah, so before we went on the short break, we looked at ISO 27. We looked at the second part of the conversation, AI governance and regulatory framework. We started discussing about ISO 27001, and we looked at some key areas of ISO 27001. So I'd like us to continue with another AI regulatory framework, that is the EU AI Act. And what the EU AI does first is that it categorizes AI system based on risk. It does a very elaborate um, risk classification. And from experience, I think the UAI Act has the most stringent risk-based classification, and it categorizes risk into four categories. First one, unacceptable risk. Second, high risk. Third, limited risk. And fourth, minimal risk. The unacceptable risk. So the unacceptable risk is the same as banned use of AI within the EU. So for the unacceptable use, nobody's expected, no organization is expected to no organization is expected to implement AI for use in the banned category. And the banned category is like social scoring, like using AI to score people into demographic. It is banned. Then also real-time biometric surveillance using AI is banned. And also using AI for manipulative purposes is banned within the EU. The second category is high risk. And for this high risk, there are strict requirements, strict controls that are required to be implemented for high risk. And these high risk are critical infrastructure. So when you're using AI in healthcare, you're using AI in for critical infrastructure, you're using AI for uh, power grids, electricity, for water systems, for transportation systems, such as trains and air navigation systems. There are a lot of strict controls. Also, the use of AI in education is considered at high risk. Use of AI for employment is high risk as well. There are a lot of controls that the EU AI Act has. And also the use of AI for law enforcement. These are high risk use of AI within the EU. Then there's limited risk. So limited risk for things like chatbots, those are limited risk. Then minimal risk, that's spam filters, AI-enabled games, inventory management. So the EU AI Act has categorized the use of AI into four major categories. And depending on the categories you are, there are strict requirements. But let's always remember that the unacceptable risk, nobody is expected to operate within that band. Anything within that band is banned. We are not allowed to use AI in the EU for social scoring, for real-time biometric surveillance, and also using manipulative AI systems. Now, again, so one thing I'd like us to understand is that these AI management systems or frameworks, their foundational expectations are the same, but they want to see the expression of those controls in different ways. The EU AI Act has requirements for risk management. There's a requirement for data governance. So it's interested in the training data, in validation of data, in testing of data sets to ensure that they meet quality criteria. And the data must be representative. The data must be free from bias. And the data provenance, that is the history and the life cycle of the data, must be adequately documented. Also, the EU Act requires technical documentation of AI systems, and also there must be technical documentation of compliance of AI systems. So it's for accountability and for transparency. The EU Act requires for technical documentation end-to-end of how the AI system operates before it is placed in the market. Then also record keeping, traceability. The EU AI Act has some controls that require log management. The AI system must be able to generate logs of how it makes decisions so that there is traceability. We can be able to trace the functionality of the AI system. Then transparency. It must provide clear information to deployers about the system's capabilities, limitation, and intended use. Transparency. So, for example, if you are using ChatGPT or Claude, you can see something that is just when it generates an output for you, it's writes something about this is AI generated and might contain some errors. So, transparency. What is the use case of that AI tool? Then, if the AI tool has got some limitation, there should be documentation of the limitation that must be transparent to the users. And also, the intended use of the AI must be shared with the users of the system. Then, like we discussed earlier, there must be human oversight. Critical AI systems should not be for critical decisions. AI systems should not make the final, should not make the final call. So there must be human oversight. Some people call it human oversight, some other people call it human in the loop. It's still the same thing. So that before critical decisions are made, then before critical decisions are made, human beings must review to ensure that the accuracy of the decision, because it is before they are fed out to users. Then accuracy and robustness, and also conformity assessment for accuracy and robustness. So there must be an accuracy requirement. So what type of output are we expecting from the data? Then also robustness. For robustness, what we mean in robustness is that how do we expect the AI system to behave in cases when it's been attacked, or when the AI system senses that something is going wrong? How robust should it be? How do we expect it to behave? That should also be robustness should be built into the AI system. And also cybersecurity is not, that is a no-brainer anyway. Cybersecurity is a cardinal requirement, must be documented and must be implemented throughout the life cycle of the AI system. And also conformity assessment. AI systems should be reviewed. Risk assessment, penetration testing, impact assessment that looks at bias, that looks at societal impact, then also risk assessment should be conducted, governance assessment should be conducted before these AI systems are being put on the market or they are being given to users. And also, and again, there are a lot of third-party certifications that our tools can go for. For example, the for 2001 certification again proves that the AI system is being governed, risk assessment is being conducted and is compliant. So that can be a third-party certification that an organization might decide to have to prove to its customers that the AI is properly governed. The third one we'll discuss today is the NIST AI risk management framework. For the NIST AI management framework, it has 4 categories. The first one is govern, map, second one, third one the fourth one is the fourth one is manage. Now for the govern, the organizer must be able to show management and oversight of AI within the organization. Management responsibility, AI policies, AI procedures, AI policy, AI procedures, the scope of AI, and like a AI charter within the organization. Then the map looks at context and risk identification. Then for the measure, at the govern and at the map side, we'll have already we'll have already developed and set up the KPIs through which we measure our AI systems. Then at the measure, this is where we now quantify and we track, identify risk. This is also where we measure the performance of the AI system. Then for the manage is where we prioritize and we act on AI risk, also where continual improvement goes on. Then specifically for the UK, there is the UK AI Act, and it has five principles, pardon me, which are not different from things we've discussed previously. There is the safety and security and robustness. We've explained that safety, human life, the society, security, the confidentiality, the integrity, the availability, the privacy of AI systems, and also the robustness. When the AI system senses that something is going wrong, how does it operate in that time? Does it totally shut down, or does it have capabilities to ignore um, the adversarial attack and still give outputs that can still be trusted? Then transparency and explainability, we've also discussed that. Fairness and non-discrimination. The AI system should be representative. There should be no bias and discrimination to any geography, to any demography, or to any race. Then accountability and governance within the governed stage. Who is accountable for AI outcome? Who is responsible? The RESI matrix. Who is accountable? Who is ultimately accountable? Who is responsible for AI decisions within the organization? And usually this is a gray area within organization. So is it the software developer uh, or the data scientist that is responsible, accountable, or is this management that is ultimately accountable? So again, as part of the governance as part of the governance setup, the accountability and responsibility for AI decision and outcomes should be determined, documented, and approved. Then contestability and redress. So AI decisions there should be a mechanism for users to contest AI decisions. And when AI decisions are contested, there should also be a mechanism to ensure that adequate response or adequate explanation is given when contests are being made. There should be a process through which we can address concern on AI output. And when we find out that the AI decisions are wrong, we should be able to have a process for redress, for reviewing, for retraining this AI data. So these are the five principles within the UK AI Act. Yeah, so this is documentation for mapping 27001 to other existing AI governance principles, and this slide will be shared at the end of this session. So the 27001 domain, risk assessment, we discussed about risk assessment. Asset management, we should have an AI. So again, we have all these processes that have been listed there. For those of us who are practitioners in cybersecurity, we have these processes already. These processes are not new. But then we now need to embed AI in these processes. We've always conducted risk assessment. What we just need to do is to ensure that our risk assessment covers AI systems and AI risk. We've always had asset management. What we now need to do is that AI assets now needs to be included in our AI asset management, so that AI model, training data, our pipelines needs to be, we now need to add them into our asset management. Of course, we've always had access controls. Every organization that is what is onions in cybersecurity has had access control. But then we now need to look at access controls into AI system. We've always had supplier relationship. We've always done third-party risk management. Now we now need to add AI systems into our risk management. We've always had incident management, but there are now specific AI risk AI incidences such as bias, model failure, adversarial events that we need to embed within our incident management process. So basically what we're saying is that AI, the introduction of AI into our systems means that we now look at all our AI, we now look at our existing cybersecurity processes to ensure that we cater for AI asset, AI risk within our existing cybersecurity processes. The last thing we'll talk about today is AI risk assessment foundation. And here we'll look at AI lifecycle risk, we'll look at threat modeling, we'll look at data supply risk, and one take-home assignment will be given at the end of the session. So risk across AI lifecycle. AI lifecycle, AI, every information asset we use within an organization has a life cycle. There will be the point where we begin to use it, and there will be a point where if the organization stays long enough, there will be a point where we stop using it. And AI has a life cycle, and across the life cycle, what are the risks that comes up across the life cycle? Number one, the beginning of AI is data collection, especially for organizations that are training models. And at this point, what are the risks? Bias, privacy, violation, and poisoning. For privacy, we'll discuss it more elaborate next week. But for privacy violation, this data we are getting, are there privacy constraints on this data? For example, if we are training AI models within an organization and we have customer data, do we need, based on the contract we have with our customers, do we need to inform our customers that, hey, we are trying to develop an AI model. We want to use your data for privacy. Can you give us consent? For privacy, consent is a cardinal requirement for privacy in AI system. Also data poisoning. Then during model training, what are the things we look at? Backdoors, overfitting. Overfitting is when we have a model that works perfectly in training, but it works perfectly in training. When you are testing it, it works perfectly well. But when you now put it in a real world situation, it underperforms. Then, of course, our intellectual property theft. Then for testing and validation, we want to ensure that we have done adequate adversarial testing. For deployment, because again, these AI systems don't stand alone. Probably we have integrated AI system into our fraud detection. We have integrated AI system into our banking, into our core banking application, or into our core systems. So we want to look at, and most times they communicate through AI API connections. So we want to look at API attacks. We want to look at prompt injection. We want to look at model theft. Then for monitoring, we want to look at drift and degradation. So what is drift? When these AI systems are set up, we set them up to do some things and based on the training data. But then what happens is that, okay, let's use fraud detection as an example. So you implement a fraud detection tool. And when you implement this fraud detection tool, the training data you use is based on the current fraud threats that are available. But as you keep using these systems, we agree that fraud trends and fraud attacks, they begin to evolve. So at some point, if we don't conduct adequate and constant retraining of the model, we find out that the tool that we have implemented does not meet the business reality and is no more useful. So the fraud detection tools are not able to detect 0 day, they're not able to detect the most recent. So that means that the AI tool is beginning to degrade, And for degrading, we need to ensure that we do adequate and constant training and all for emerging threats. Then for AI threat modeling, applying stride. So we've got there are a lot of AI threat models out there, and we can engage anyone for our use case. There's spoofing, that is fake training data sources, impersonating legitimate data pipelines. There's tampering, that is data poisoning. Adversarial perturbations. For these adversarial perturbations, that is when a malicious person slightly manipulates data, input or training data, slightly manipulates it. And this slight manipulation might not be noticeable to the ordinary eye. I'll give an example. For example, we've trained a self-driving car to recognize colors or to recognize a stop sign. It understands what a stop sign should be like. Then someone now goes to manipulate just one dot on the color. When that is done, the AI system interprets it wrongly. Then that stop sign is no more stop to it. It means something else. So when it gets to a stop sign, it keeps moving. And again, that is disastrous. That is tampering. The next one is repudiation. We must be able to explain how AI models make decisions, and we must be able to trace how these decisions are made. Adequate logging. Where did he get this data from? How was he able to process this? Based on what data? Based on what algorithm? And who imputed the data? How did he come to the outcome? Non-repudiation. Then information disclosure. We should guard AI system against model inversion, membership interference. Model inversion, we've already discussed this earlier, where someone maliciously craft input into an AI system with the view that the AI system is going to divulge critical information about itself. Then denial of service, of course, this is what we don't want. For any AI systems that we are implementing, what we want is that we want availability, so that when internal users or customers are trying to access the system, they can access it and they can use it for business function. We don't want to, so uh, things like resource exhaustion. Again, AI system, the work on they uses AI system uses a lot of hardware resources depending on the weight of the model or the kind of processing it does. So we really want to look at our infrastructure, especially for most AI systems. They are they are hosted in the cloud. So we really want to look at our resource allocation to be able to ensure that at peak hours, we have provisioned enough resources for this system to do their computing and to provide adequate feedback to customers. And also, apart from resources, we also want to ensure that we guard against adversarial attack that might bring down the AI systems. Then elevation of privileges. We want to ensure that AI systems or physical users. So there's this risk for AI systems where AI systems are being used for so long within an organization, it begins to get rights and privileges into systems or into domains where it's not supposed to get access into. So our API connections, the uh, service accounts that we are using, the service accounts that we're using in our AI systems, who are the owners, who is accountable for it, and service accounts, do physical users, do they get the only the level of privilege they need? Do we use the principle of least privilege in granting access to AI system? Also, we'll look at data and model supply chain risks. And for most organizations, they use pre-trained models. So how are we reviewing those models to ensure that they don't contain backdoors or biases or vulnerabilities before we impute them into our training systems? Also, for our training data set, so what happens most times is that most organizations scrape the internet for training data. So this training data that we are scraping, are we ensuring that they don't contain bias, or they are not copyright data, or they are not deliberately poisoning content? Also, we want to look at the sufficiency of the data. Do we have sufficient data? Is the data we are imputing into our training system, is it sufficient for our use case? Also, we want to look at excuse me, we want to look at the libraries and the machine learning the machine learning libraries and frameworks that we are using. We also want to look at the API-based services, the third-party API tools that we are using. We want to ensure that they are secure enough for our use case. Now, we've had quite some conversations on this call, and in summary, what are the key takeaways? First, AI systems present fundamentally different security challenges compared to traditional IT. So therefore, we should rethink security. We should look at security difference whenever AI is being put into the mix of our information processing facilities. Now we look at 6 key AI threats to watch: adversarial attack, data poisoning, model inversion, prompt injection, model theft, and supply chain attacks. Also, we've looked at governance frameworks such as ISO for 2001, the EU AI Act, the NIST AI framework, and the UK AI framework as well. And what they do is that they provide structured approaches to managing AI risk. Also, we've looked at how we can conduct risk assessment that spans the entire AI life cycle. Yeah. So thank you very much for staying put for 1 hour plus. And this is the time where we open the floor for questions, for suggestions. Of course, I'm not the connoisseur of all knowledge. If there are some additions we'd like to make to the discourse, or if there's any other perspective we want to bring into this conversation, we are welcome. So I guess that can be done either by raising up the hand, or probably if you want to send your questions or your observations into the chat box. I think that is welcome. So I'm handing over to Wale at this point.
Thank you,
very
TOLUWANI, and appreciate you so much for sharing with us this evening. Thank you, quite comprehensive. There was a question before the second part. Maybe you can start with that, where someone was asking, how do you begin this discussion with top management?
Okay. Okay, that's fine. Okay, so how do you begin this? Thank you very much. Izuna. Yeah, how do you begin this discussion with top management? How do you begin to implement this governance structure from your experience? Who heads the structure? So AI governance is not totally different from governance structure we have in an organization, and it is best to embed AI governance into existing AI structure. However, we might need to now introduce people with some specific skills, or train people within our governance setup, train them on some AI specific governance knowledge. So basically, how do you begin to implement this? So the first thing is to talk to those involved in governance, is to really expose them to the risk of shadow AI or unregulated AI use within an organization. There must be accountability and there must be responsibility for AI use within the organization. And who heads this structure? It is best to ensure that management carries the accountability. The highest management within the organization carries the accountability for AI, because AI is either improving business processes or helping customer to use our services better. So it is best that the same structure we have for governance of cybersecurity, we have it for AI. However, there might be need for new skills, because these people must understand bias, they must understand safety, they must understand AI impact and the new challenges that AI brings into the ecosystem. I hope that answers your question. Then there is Ugo.
There's a
How does that?
Right.
Yeah.
Go ahead.
Okay, so Ugo is saying, how does an organization strike the balance between managing model poisoning and training? We need large data set to train models, and in many situations, such big data exist on many databases which are restricted from interacting with models. I ask this question because employees of many organizations are complaining that they are not deriving ultimate value from using bespoke AI models because of the limitations I mentioned. Thank you very much for this question. And this question presupposes that you're a practitioner within the AI ecosystem. So I think the first thing is that, especially for organizations that are building in-house AI system, is at the project initiation, when we are scoping the project, to understand, number one, what do we need this data, what do we need this AI for? What is the use case for this AI? What type of data will we need to train this AI system? Now, at the point of looking at the type of data, we look at, number one, what type of data, what are the sources of the data, and what are the limitations to getting this data. Very, very important, because even apart from the large data set that you need to train, there might be some privacy constraints on those data. At times, you might even have those data, but then you need to seek consent. And we know the way consent is like now. Most people don't want their data used for other systems rather than for the purpose it was gotten. So if we now find that there will be challenges in sourcing for data, we can now use an approach that can we now use synthesized data. There is option of using synthesized data. And what are synthesized data? They are data that will develop within the organization that mimics the real world data for our use case. Again, that has its own drawbacks in the sense that it might not be as accurate as the it might not be as accurate as the real world data. But then again, as we keep using it and as keep training, hope it might get better. Then there are a lot of data sources, although again that comes with a lot of cost, because you might need to buy those data, you might need to do some provenance, you might need to do some sanitization. But then at the point, I think the best thing is that at the point of initiating the project, we should look at our use of data. Where are we going to get it from? And what kind of data will be sufficient? So at that point, decision will now be made. Do we now really need to? So at that point, we now make decision. Do we need to build our own models, or do we go for existing models, which will be cheaper and which will be better for our use case? And of course, that is a management level kind of decision. So I hope that answers your question. Yeah. So Glow is asking, are we getting the recording? I think Wale will.
Yeah, get it recording.
Yeah. Think okay. Thank you very much for that. Then the next question: what steps can one take to begin the conversation of embedding AI within third-party risk, especially assessment, where AI governance is non-existent within the organization? So I think the first thing is always to start with the governance. You can't start building a house by fixing the roof first. You need to start from the foundation. The foundation is AI governance, because it's AI governance that is even going to give you uh the mandate to conduct a third party risk assessment. So I think governance, ownership, scope, and of AI systems is the first step. Then in the case organization is using, that is Ungo. Hope I pronounce your name appropriately. In the case organization is using third party AI
You answered
systems.
that one already.
Oh,
I think the next one. Oh, sorry. This is the one you look at now. Sorry. Go ahead, please.
okay, that's fine. In the case organization is using third-party AI system, how can the organization control and govern the use of ChatGPT, Claude, and Copilot? So first, there should be AI management policy, and in our AI management policy, or as a standalone policy, there should be an acceptable use of AI. Now, what type of AI do we allow as an organization? And also we should implement technical controls as well to ensure that staff cannot unilaterally download um or even if they download, they can't install these AI tools. And we can also block these AI tools using URL. So but first it starts by governance. It starts by setting out what third-party tools do we want, what do we use them, what do we want to use them for, what are our use cases. and also implementing technical controls to ensure that they are not used within the organization. We can block them at URL. We can stop. We can prevent staff from installing those tools. Yeah, thank you very much for that. Then Ruth is asking, you said earlier that black box has become a risk. Yeah, it's a risk, but I didn't specify Nigeria. It's a global risk. It's a global risk. So you said earlier that black box has become a risk in AI. Could you please give some example of this risk? Yeah, so black box is when we can't explain how AI comes, how AI systems are made their decision. So for example, let me give an example. So for example, we have an AI tool that we're using for recruitment, and someone's CV has been rejected. And there's now a question that, okay, why is this CV rejected? What is the criteria? What are the criteria or the basis for which this HR tool has rejected this CV? Can we explain how the system process? That is a black box when we can explain how AI system makes its decision. So can we explain how this system has blacklisted this CV, or for AI systems that we use for credit processing? Someone has applied for a loan and it's been rejected. Why did the system reject the person? What are the criteria through which this decision was made? So that is example of this. So I think that is all the questions we have in the chat box.
That's all. There's no other question in the chat. Oh, there's a question. There's one question in the chat, but I think we just drop another question. You can answer that and then we can close.
Okay, that's fine. So Ugo is here again. Are the AI model adopted in Nigeria? The AI models adopted in Nigeria are trained with data in other clients. Wouldn't this intro exactly? This is what we are saying. So bias, yeah. So exactly, I like your question. So bias is ensuring that to prevent bias, what we want to ensure is that the data we have used is representative. So for example, what we are saying that most AI data used in Nigeria are trained with data from other clients. So for example, if I'm building a credit rating system, and I'm using data for credit rating from the UK or from Europe, the demography is different, the regulatory requirements are different, the operationalities are different. So definitely when you train with those data and you put it into operation, you don't expect the AI system to perform optimally. So what we are saying is that whatever data that we're using to train our AI system must be representative of the population to ensure that bias is limited from the output. So we should ensure that the data that we're using is representative. If you are going to build a tool that will be used in Nigeria, where are you getting your data from? The countries you're getting the data from, are they having the same operations? Are they having the same, okay, for example, if you are using either a climate, or you're using something about climate, AI climate system, and you are using data from countries that have winter, that has autumn, into Nigeria, where we have Harmattan, we have rainy season, of course, you know that the data will be skewed. It's not representative. So what we need to do is that we must ensure that the data we use is representative of the population or the environment where the AI tool is going to be operational. Thank you very much.
Thanks, Toluwani. I think we will close the shop at that point. One thing I would like to contribute on this data being trained, or the models being trained with data that is not Nigerian data, is that I think culturally, most people don't like to volunteer data. They don't like to provide data. So you have to be intentional. If they are gathering data and you're not willing to volunteer data, then you cannot complain if the output is biased. So we have to be intentional about contributing to the input, because that input, as Toluwani has said, will eventually determine the output. So if someone is building an HR system or any system, and they are looking for people of color, and you are not willing to provide data, it means that they will build that model with the data they have, And definitely, when you come as a person of color, it will not be able to, it may not be able to recognize your characteristics, and that model will be said to be biased towards some categories of people. We will take this forward from next week at the same time on the 28th. And thank you for joining. If you joined us for the first time, Cybersecurity Mentoring Platform is a platform where we invite experienced professionals to share an important topic in cybersecurity, and also their journey in cybersecurity, which we have on next week Saturday. We'll have that session, and also we have master classes. And for now, we have these programs for free for everyone that attend, particularly because we have generous facilitators like Toluwani here. And so if you are not part of the group, you can check us on LinkedIn. We're on LinkedIn to join the group, because we often announce programs or masterclass that we hold on the group. In fact, we have closed application for a masterclass that will start on the 1st of April. We're currently analyzing the applications to then send out acceptance to people that we think are good for the class. We'll be having building proofs is a practical sessions on different projects across different areas of cybersecurity, just to give people head start, people who haven't touched system before, to be able to build some competence and confidence when they go for interview. That will kick off by April first week. We've gotten almost 90 people applying, so we'll go through the list and see what we then do with the application. Thank you, and we will catch up again next week at the same time on the 28th of March. Bye for now. Thanks so much, Toluwani. Thank you for your contribution to the community, and also for sharing your knowledge with us this evening.
Thank you for having me.
Do have a good evening. Bye.
All right, bye.